Hello, I'm Linwood Fields, your green instructor. Welcome to Lecture 3 of 5th grade Green Math. Lecture 3 is on addition. The objectives: understand addition at the most basic level. Demonstrate the commutative property of addition. Know how to represent dollars and cents as decimal numbers. The fifth grader should know that decimal numbers allow us to represent amounts less than 1 or amounts less than a whole. Now, this objective should already have been met because that's what we discussed during the last lecture. So if you need some review, please go back and look at lecture number 2. The fifth grader should know how to add decimal numbers, which is basically the focus of this lecture. Addition fundamentals. Counting is more fundamental than adding. Addition is just a quick way of counting forward. Yes, addition is not as fundamental as counting. Addition is simply a quick way of counting forward. When we add, we are either memorizing the sum of two numbers or we are counting in our heads or on our fingers. I hope that you are not counting on your toes or adding on your toes. This is toe counting. Let's say that we have 4 objects that we count on our left foot using our left toes, and we add that to 3 objects that we're counting on our right foot using our right toes. So 4 plus 3 is 7. Of course, toe counting is not so cool. I would much rather use addition because it is quicker. Adding is counting forward, memorizing that two numbers have a certain sum. For example, 2 plus 3 is equal to 5. That is not fundamental. Starting at 2 and then counting forward or up 3 times is fundamental. A picture of this process is shown below. Okay, let's put our finger on the number 2. Now we're going to move over 3 humps or 3 places to the right. The right represents counting forward. Okay, so we started to 1, 2, 3. So we move over 3 humps, and then we see that we end up on the number 5. So what we have done is added 3 to 2 by counting over 3 units. 2 plus 3 is equal to 5. Now let's look at the commutative property of addition. Question: would you want to start at 35 and add 1072 by counting up? I certainly would not like to add such a large number to 35 by counting up. I would rather use the much faster technique called addition to add these two numbers. As a matter of fact, there is a rule in addition that lets us start at 1072 and then add 35, and we get the same answer as if we had started at 35 and added 1072 to 35. Okay, let me repeat that. I can add 35 to 1072 rather than starting at 35 and having to count all the way up to rather than starting at 35 and having to add 1072 by counting up. So the reason we can do that is because of the commutative property of addition, which says that the order in which we add two numbers does not matter. For example, 10 plus 8 is equal to 18. 8 plus 10 is also 18. So here we started with 10 as the first number and we added 8. But we can start with 8 as the first number and add 10 because of the commutative property of addition. Now, this commutative property of addition rule is true because of the nature of counting. Yes, addition is just a quick way of counting forward. A quick review of place value. On this electronic adding machine, consider the decimal number shown, 68.25. The 2 is in the tenths place, and the 5 is in the hundredths place. Also, from our review or from our understanding of place value, we know that the tenths place is 10 times larger than the hundredths place because the tenths place is one place to the left of the hundredths place. Here, we're going to demonstrate adding decimal numbers. Okay, what you see here is some ice cream cones that cost 50 cents each. Let's assume that you have 19 cents and your friend has 39 cents. And you want to buy an ice cream cone. And again, each one of these costs 50 cents. Do the two of you have enough money? Okay, remember, you have 19 cents, your friend has 39 cents, but each ice cream cone costs 50 cents. So do we have enough money? But first, we need to know how to represent cents as decimal numbers. Okay, let's look at representing money as decimals. We know that 1 penny is 1 cent. It takes 100 pennies to make $1. Since it takes 100 pennies to make one whole dollar, then each penny must be 1/100th of $1. 1 penny is 1 cent and is represented as $0.01. So this is the dollar symbol, $0.01 or 0.01, which is 1/100th of a dollar, is 1 penny. Notice that 1 cent is 1/100th. That's what we have represented here, 1 cent, which is 1/100th. 2 pennies is 2/100ths, represented as $0.02. 8 pennies is 8/100ths, represented as $0.08. 10 pennies is 10/100ths, represented as 0.10. We know that 0.1 is 1/10. Therefore, 10/100ths is the same as 1/10. So let me repeat that. 10/100ths is the same as 1/10. There are 10/100ths in every 1/10. And that's the same as what I just said. 20 pennies is 20/100ths, represented as $0.20. We know that 0.2 is 2/10. Therefore, 20 hundredths is the same as 2/10. So the fifth grader should be able to extend this line of reasoning to represent 30 pennies. They should be able to represent 50 pennies. They should be able to represent 60 pennies. Now, what about 15 pennies? How do we represent 15 pennies? 15 pennies is the same thing as 15 hundredths, which would be 0.15. So 15 pennies is $0.15. So again, the fifth grader should be able to represent any number of pennies in terms of money. Okay, let me erase this. The beauty of decimal numbers is that they allow us to represent amounts less than 1 or amounts less than a whole. $1 is equal to 100 cents, which is equal to 100 pennies. So we see that 1 penny is equal to 1 cent. It's equal to 1/100th of a dollar. Now imagine this array, which is an orderly combination. Imagine this array of numbers represents $1. We see that our dollar has been divided into 100 little square pieces. Now, because 100 cents is equal to $1, that means that each one of these squares is 1 cent or 1 penny. We emphasize here that coins, pennies, nickels, dimes, and quarters are the decimals of money. Yes, coins are the decimals of money. Coins allow us to represent amounts less than $1. Okay, back to our example. Remember, we're trying to decide if you and your friend have enough money to buy one ice cream cone that costs 50 cents. You have 39 cents. Your friend has 19 cents. 19 cents is 19 hundredths, represented as $0.19. 39 cents is 39 hundredths, represented as $0.39 or 39 hundredths of a dollar. Using pictures or counting, let us now add 19 cents to 39 cents, or rather, we're going to add 39 cents to 19 cents. First, we're going to select our 19 pennies because we are adding 39 to 19. 19 is what we're going to start with. So that's shown right here. We have selected 19 pennies. Now, we're going to add our friends, your friends' 39 pennies to your pennies by counting up from 39. So go ahead and place your finger on 19 because you have a total of you have a total of 19 cents. Then count off 39 more squares. Remember, each square is 1 penny, so we're going to be counting off 39 more pennies. Okay, now each row is equal to 10 pennies. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I got 1, 2, 3 rows of 10 pennies, that's 30 pennies. Plus this one here is 31, 32, 33, 34, 35, 36, 37, 38, 39. We see that we end up on square number 58. So you and your friend have a total of 58 cents or $0.58. So remember that each cone costs 59 cents or 50 cents. So what we have to do now is compare 58 cents to 50 cents. So if we compare 58 cents, which is 0.58, which is how much money you and your friend have. Remember, we know how to compare numbers, even decimal numbers. The first digit in both numbers is the ones place, and remember we said that zeros really don't add any value. So really the first digit or the first place that's not zero is the tenth place. Both numbers have the same digit, which is 5 in the tenth place. So according to our comparison recipe, we have to go to the next largest place, which is the hundredths place. Now, this number has an 8 in the hundredths place, hundredths. And this number has a 0 in the hundredths place. Okay, so this number has an 8 in the hundredths place, and this one has a 0 in the hundredths place. Because 8 is larger than 0, then this number here, 0.58, is larger than 0.5. So you two have enough money to buy an ice cream cone. Okay, since the ice cream cone only costs 50 cents, which is half of a dollar, which is 0.50, then we see that you two have enough money to buy the ice cream cone, and we'll have some money left over. You will have to figure out how to share the ice cream cone. We represented the half dollar as 0.50, not 0.5. Why did we do this? Well, because our other decimal numbers are represented as hundredths. Remember, we had 19 hundredths and 39 hundredths. And more importantly, the number that we want to compare is 58 hundredths, not tenths. 0.5 is 5 tenths. So we want to write 5 tenths as its hundredths equivalent, which is 0.50. Now 0.50 has the same value as 0.5, but they are just represented differently. Again, we want to use this representation because the other numbers that we're dealing with are represented in the hundredths place. Earlier, we established that there are 10 hundredths for every 1/10. So if we have 5 1/10ths, this means that we have 50 hundredths. When adding decimal numbers, we want all the decimal numbers to have the same number of digits to the right of the decimal point. And that's what we did up here. If the decimal numbers do not have the same number of digits to the right of the decimal point, then we add zeros as placeholders until all the numbers do have the same number of digits to the right of the decimal point. 0.5 only has one digit to the right of the decimal point, whereas 0.50 has two digits to the right of the decimal point. So what we did is added a 0 here as a placeholder so that this number has two digits to the right of the decimal point. Now, adding decimal numbers without pictures or without counting forward is easy. Here is the recipe. Step 1, write the decimal numbers down and make sure the decimal points line up. Step 2, add zeros as placeholders so that the decimal numbers have the same number of digits to the right of the decimal point. Step 3, go ahead and place a decimal point in the answer before writing down any digits in the answer. Step 4, forget about the decimal point and add the numbers as if you were adding whole numbers. Okay, adding decimal numbers without pictures. Let's go ahead and add the 19 cents and 39 cents from the ice cream example. Step 1, write the numbers down so that the decimal points line up. We see that the decimal points line up right here. Step 2, both numbers already have the same number of digits to the right of the decimal point. Both numbers already have two digits to the right of the decimal point, so we don't need to add any zeros. Step 3, go ahead and place a decimal point in the answer. So you draw your horizontal line and then put a decimal point in the answer before we start placing any numbers in our answer. Step 4, forget about the decimal point, forget about the decimal point, forget about the $ symbol, and add the numbers as if they were just whole numbers. Notice that 9 plus 9 in this column is 18. We write the 8 under the 9 in the hundredths column. We carry the 1 over to the tenths column and add 1 plus 1 plus 3, and we get 5. We are finished. That is all there is to adding decimal numbers. Now here's an activity that you really should do to get a good feel for the fact that coins are the decimals of money. Please do not skip the activities. And this character here, this is Monique. She's our money expert in 5th grade green math. Summary. Addition is simply a quick way of counting forward. The commutative property of addition says that the order in which we add two numbers does not matter. Decimal numbers allow us to represent amounts less than 1 or amounts less than a whole. 1 penny is equal to 1 cent, which is equal to 1/100th of a dollar. $1 is 100 cents. This is the way we write 100 cents. 1.00, which is 1/100th. So what would $2 look like? So $2 would simply be 200 cents, which is 2.00. Now, what about $2.35? $2.35 would look like have a 2 in the ones place. That's $2 and 35 hundredths because that's 35 pennies. Let's erase this. And the last bullet in the summary is adding decimal numbers is basically the same as adding whole numbers. Now, see the end of lecture 4 for questions and practice problems because lecture 4 is subtraction. This is the end of lecture 4. This is the end of lecture 3. I hope to see you the next time for lecture 4. Goodbye.